Four then is the growth in decay question. Now, obviously, there's a lot of reading that you need to go through. I'm going to get straight to the point of this question. So we've been given a formula. So the formula is m equals m naught k to the power of t. And we've told what all these things are. So we're told that the radioactive iodine reduces from 224 grams to 12. So the starting weight was 24 grams, and it's been reduced to m to 12 grams, and the time is 8 days. Now we've been asked to show that k is equal to a value. So obviously we need to make sure we substitute everything into the formula correctly. So this is the first stage of our show that. 12 equals 24 times by k to the power of 8. So then we can say, well, half dividing both sides by the 12 equals k to the 8. And you can take logarithms. I'm just going to take the 8th root. So the 8th root of a half is equal to k. Now we'll do that on our calculator. Oops, wrong calculator. Here we go. We'll do that on our calculator. So the 8th root, which is this one here, 8th root of a half, pop that in there, and we get the value. Now you must make sure that if you're asked to show that it's something correct to 6 decimal places, you write it out more than that. So 0.917004, that's fine, but put the whole calculator display down because you're showing that it rounds to that. So therefore you need to show more to show that when you round it, it is correct. Now, if you read the mark scheme carefully, it implies, and I think this is most correct, I didn't mark for the examiner, so I'm not 100% sure, but you did not get the mark if you wrote this, if you just wrote down k and didn't say what it was longer, rounded to 6 dp. Okay, so really important that you just take a little bit longer and you just write down that step as well. Now we've got a similar sample. So to be a similar sample, that means the value of k, that constant, is the same. So for part 2, value of k is what it was, but let's just read it through. So it's reduced in mass to 1 gram after 60 days. So m0 is the thing we're trying to find out. What was the initial mass? We know that the reduced mass was to 1, we know the time was 60, and we know that k is this value that we were given in our question. So let's just set up the equation with everything we know. 1 equals the thing we don't know times by 0.917004 to the power of 60. Okay, so that's all of the information that we've got. Just make sure that looks like a 1 there. And now we're ready to try and solve the problem. And it is quite a simple solution because we're trying to find m0. So we're just going to divide by everything else by 0.917004 to the 60. So 1 over 0.917004 to the power of 60 is equal to m0. So we're just going to pop it into the calculator. I always put everything I'm substituting in brackets just in case. So 0.004 to the 60. And the solution that we get is the correct answer, so 181.0198. Again, checking the question, give your answer to the nearest gram. Don't lose silly marks by not reading the question, so it's 181 grams. Now, part B, this is something a little bit different because we've now got a radioactive substance and they're trying their best to tell us that K's changed here. So we're now going to work with a different value of K. So this new K, or this new situation, we've been given the information that we're looking at half-life. We're trying to get mass to go from m0 to half of m0. So we're told that the radioactive vanadium, probably not the correct pronunciation, starts with its m0. Oh, sorry, I haven't got the pen out. Starts with m0 being equal to 10. And then after 100 days, we get down to m at 8.106 grams, and that was 100 days. So it hasn't hit its half-life yet. So if anything, the only thing we can conclude at this point is that it's going to take, T is going to be more than 100. And K is now unknown. So we're in a new situation. So we've got to, first of all, use the information we've been given to find this value of k. So exactly the same thing that we did earlier for part 1. We're going to set up an equation with k being unknown. Divide through by the 10. So 0.8106 equals k to the 100. And then we'll take the 100th root of 0.8106 to find the value of k. So let's do that. We'll take the 100th root of this value here. So our new value of k, so it has changed, is 0.997902. Let's go 6 decimal places because that's what we want us to do earlier. So that's our value of k. Now we're asked to work out how the half-life works. Find the half-life of this radioactive substance. So what does that tell us? Well, that tells us that whatever m0 is, that's equal to whatever, m is going to be half of m0. Now, if you wanted to, you could just put a value in here. You could put 10 and 5, and it would work. But let's go as sort of theoretical as we can. So we've got m0 is equal to m0. Our m is a half of m0. Our t is the unknown. And our k is what we've got up here. So let's just pop all this into the equation that we've been given. So half m0 equals m0 times by k to the t. So 0.997902 to the power of t. So at this stage, if we divide both sides by m0, just write down that I'm going to do that. That m0 cancels with that m0. So we end up with a half is equal to 0.997902 to the t. So the issue we have here is that t is obviously exponent, and I can't do the tth root of something on my calculator. So I am going to have to take logs. I'm just going to scroll to give myself a bit more room. So actually I'm going to take luns because it's just easier button. Equals the ln of 0.997902 to the t. Third law of luns or logs says that the t can come to the front. So I've got ln of a half, let's change it to calculator input, equals t ln of 0.997902. And then finally, t is going to be the division of those two logarithms. So I think for this question, it's not really the mathematics that's the big challenge here. It's actually just working out exactly what you've been asked to do. So I'll just conclude the question. So we've got ln of a half, and no, don't really want tan of anything. Ln of 0.997902, and that gives us t equals 330.04 days. And once again, just checking, give your answer to the nearest day, so make sure you do that, 330 days. Okay, so in this question, we said at the beginning it was going to take more than 100, and it certainly did. 330 days for the substance to decay to its half-life.